Hello everyone, welcome to Haematology Made Simple. The purpose of this channel is to make haematology as simple as possible for all students and practicing hematologists. Hematology is the study of blood and blood disorders. For simplicity, we are going to divide our presentations into different sections. We are going to be looking at the study of erythrocytes and erythrocyte disorders, study of leukocytes and its disorders, and the study of thrombocytes and its disorders. In our section 1, we are going to be looking at the Haemopoetic system, erythropoiesis, red blood cell morphology, and anemia. While discussing anemia, we are going to look at the physiological classification and morphological classification. And at the end of our presentations, we will be able to make all these topics as simple as it should be. To start with, we are going to be looking at haematopoiesis in embryo and adult life. Depending on the site of blood production, it is categorized into 3 different stages: the mesoblastic stage, hepatic stage, and myeloid stage. In the mesoblastic stage, the site of blood production is the yolk sac. In the hepatic stage, the site of blood production is the liver and spleen. And in the myeloid stage, the site of blood production is the bone marrow. Looking at the period at which each stage starts the commencement of blood production, you can see that each stage takes over from the previous stage. But in adult life, if the bone marrow is challenged, that is, it is unable to produce enough blood cells, the liver and spleen start the production of red blood cell, which results into increase in size. This is known as extramedullary haemopoiesis. And also during the intrauterine life, if there is a challenge on the red blood cell, the liver and the spleen takes the major responsibility by becoming bigger, increasing in size to be able to cope and compensate with the challenge. This is noticeable in hemolytic disease of the newborn, where there is hepatomegaly and splenomegaly, depending on the degree of or severity of their condition. Erythropoiesis. Erythropoiesis is the formation of a mature erythrocyte from pluripotent haemopoietic stem cell. The pluripotent haemopoietic stem cell has the capacity to differentiate into different cell lines, but in section 1, we are dealing with the formation of erythrocytes through different stages. There is maturation and differentiation of the pluripotent stem cell to form erythrocytes. Let's now look at the different stages in erythropoiesis. Looking at the formation of mature red blood cell, it doesn't look like a pro-erythroblast. And the major difference are reduction in size, disintegration of nucleus, and formation of hemoglobin. We are going to be looking at the stages involved in the transformation of pro-erythroblast to mature red cell. Looking at the different stages, you can see the pro-erythroblast, basophilic erythroblast, polychromatic erythroblast, autochromatic erythroblast, reticulocyte, then mature red blood cell. In the basophilic erythroblast, the cell is named basophilic erythroblast because of the staining characteristics it has. When stained with a Romanowski stain, the cell absorbs the basic dye and is therefore called basophilic erythroblast. In the polychromatic erythroblast, in which there is formation of hemoglobin and reduction of the nucleus, when you stain this cell with a Romanowski stain, it absorbs the acidic dye and the basic dye. And for this purpose, it is called polychromatic erythroblast. In the autochromatic erythroblast, in which the appearance of hemoglobin is very visible and the cell stains more reddish because of the presence of hemoglobin, which is known as autochromatic erythroblast. Then followed by the reticulocyte, in which there are ribonucleic acid in the cytoplasm. And in the reticulocyte, there is a continuous production of hemoglobin until the cells becomes mature. And the mature red blood cell has a central pallor, that is, at the middle of the cell, there is little hemoglobin compared to the rest of the cytoplasm. Looking at the features of the proerythroblast, we are going to be seeing the size, the large nucleus. The proerythroblast is deeply stained with the cytoplasm of the proerythroblast is stained basophilic. Then going to the basophilic erythroblast, there is reduction in size, a slightly more condensed nucleus. Then the polychromatic, in which there is appearance of hemoglobin, the nucleus is not fully disintegrated, and the stain contains basophilic dye and acidophilic dye because of the presence of the RNA and hemoglobin. Then autochromatic, in which the stain has reduced, the nucleus has reduced, and the appearance of hemoglobin is more. We are going to be having a more reddish cell with little nucleus. Then the reticulocytes, which will contain ribonucleic acid for the production of hemoglobin. And also, this is a film showing an erythroblast and a polychromatic erythrocyte. In the erythroblast, there is appearance of a deeply stained nucleus, but in the polychromatic erythrocyte, you can see that it is different from a mature erythrocyte because of the absence of a central pallor. And to the right are reticulocytes. They have been stained with a supravital stain, and the reticulocyte, in the cytoplasm of the reticulocyte, are the RNA picking up the dyes. Thank you very much.